So in 6.3, we talked about vectors. We talked about in the beginning, this is, before I left, component form and magnitude of a vector. Component form, you're doing the second or the terminal point x minus the initial point x, and then terminal point y minus initial point y. So on this one, it would be -8 minus 1, and then -9 minus 3. And you get -9, -12. So that's your component form. So if you work this out on, what day was that? Thursday, and you already have your answer, just check your answers. Okay, then B said to find the magnitude of it. So you have two choices here. You can either work to find the distance formula given those 2 points, or you can do square root of a squared plus b squared coming from your component form. So that would be the square root of -9 squared plus -12 squared, square root of 81 plus 144, square root of 225, which is 15. Questions so far? So again, component form and magnitude, obviously things that you're going to see on your test. Okay, then it said using u is -5,3 and v is 2, -1. So you had different numbers on the video that I showed you. This says find 2u plus v. So I'm going to do 2 into the u plus v to -1. So this is -10, 6 plus 2, -1. And then again, add first and first, -8, add second and second, +5. Questions on that one? All right, 3 says 5u minus 3v. So I'm going to do 5 times u minus 3 times v. Distribute in the 5, so -25, 15. And then I can either distribute a negative or keep the negative out front, distribute a positive, and then make sure I subtract. Either way, you get the same answer. So then this becomes -25 minus 6, or -31, and 15 minus a -3, which becomes 15 plus 3, or 18. Now, because this is in that component form, I'm going to keep it in component form. Remember, if it's in IJ like the next one, you want to make sure at the end it's in that IJ form. So like 4. So 4 gives it to you in IJ form. It says u is -3i and plus 4j. And v is 2i minus j, and you're finding 2u minus v. So I'm going to do 2 times u, and then I'm going to subtract v from it. So this becomes -6i plus 8j minus 2i minus j, and that negative is going to get applied to both. And then we're going to combine like terms. So -6 and -2 is -8i. And then +8 and +j would be +9j. Again, if the question gives you the vector in IJ form, your answer needs to be in IJ form. Okay, don't lose silly points on stuff like that. All right, number 5 says find a vector in the same direction as number 1 with a magnitude of 3. And there's two types of problems with this same direction. One that said unit vector, and one that gives you the length of the magnitude. What's the difference between those two? Do you remember what unit vector is? What's the difference between a vector in the same direction with a given magnitude, or a unit vector in the same direction? Go ahead. So unit vector has to be equal to 1. You don't worry about a magnitude at the end. Whereas if it gives you a specific magnitude, we're going to find the unit vector first, and then we're going to multiply it by 3 because we want it to be 3 units long. So to find something in the same direction, we do the component form of the initial vector over the magnitude of that vector. So I already know the component form. It's -9, -12. And then we found the magnitude already from number 1. It was 15. If I didn't know it, obviously, I'd have to find the magnitude. So then these you're going to split and simplify. That would be the unit vector if it didn't give me a different magnitude. But it says it wants a magnitude of 3, so at the end I'm going to take that 3 and I'm going to multiply it in. So I'd get -9/5 and -12/5. So if your test said unit vector, it's not going to give you a magnitude length at the end. You're going to leave it where it was, and you could check it by finding the magnitude of that. It should be 1. If it doesn't say unit vector, and it says vector in the same direction with a given magnitude, then at the end you're going to multiply in whatever that magnitude is. All right, then came the graphing. So 6 said use the figure to graph 2u plus v. If it doesn't give you the actual coordinate points, like this case, then we're working off the lengths of these vectors, right? So if it says 2u, what do? Double the u. Same direction, but double its length, right? So if this is my u, I'm going to eyeball it. I'm going to say that maybe that's 2u. How do I add two vectors if I don't know their initial point or their terminal point? Make that little parallelogram, right? So I'm going to draw this out here. Well, that's not really parallel. This, let's say, is a little bit better. And then I'm going to draw this one out here. And then where they touch is going to be the terminal point of the vector that would be their sum. And yes, you need to know how to do that for your test. So if I just gave you questions like 1, 2, 1, where you had to just find the component form and then you could draw it, that's if you got your actual points, you could just draw them based on the points. But in a case like this where you're not given the actual points, you need to make sure you know how to find that length.
So if we didn't have the bone before, we would have to do it like that.
Yeah, and you won't. Yeah. Good morning. All right, so the 6, 4, 1, I'm going to change. So if you want to duplicate, if you want to go to your 6, 4, 1, I'm just going to give you new points. Okay, just 2 new points so we can practice. Everybody's changing. You can duplicate your 5, 4 warm-up and then change the point so we can practice it together. So in 6, 4, we covered dot product and then the properties of dot product. We covered the angle between two vectors and then orthogonal. So dot product, what do I do?
Can you duplicate a slide?
Can you? Yeah, just go copy paste. Like open up the, and do that. And then the 3 dots. Copy. And then paste. Andrina, I think you answered me. Okay, so 6, 5 was our complex numbers, right? So 6, 5 talked about how do you graph a complex number, how do you find its absolute value, and then how do you convert from complex number to trig form. Those were basically the 3 concepts that were in that section. So if I wanted to plot this, I could pull in just a coordinate grid, and it's the same kind of concept, except my x-axis is the real axis, and the y-axis is the imaginary, right? So this is real, and this is imaginary. So if I had -3, 5, I'm going to go left 3 and up 5 and plot a point. This is number 1, okay? So remember, these are points. These are not vectors anymore. That's a single point. And then the absolute value is just like the length that it would take, or the distance it would take to get from the 0, 0 to that end point, or the square root of a squared plus b squared, which is just like your magnitude. What's important to remember is that the b is what's in front of the I. We don't use the I, because then it would change the sign. So then this would be -3 squared plus 5 squared, and this is the square root of 9 plus 25, which is the square root of 34. This is a question that's going to be kept exact, so you would keep it exact like that. If it breaks down, that's 2 and 17, it doesn't reduce. It's going to be kept exact, so be careful. Don't get all excited that you have a calculator in your hand and try to answer that and round it, okay? You will lose points. You need to keep it exact. 2 is -5i, so this would be 0, -5. So I'm going to just go down 5, plot my point. This would be 2. And then I would get the square root of 0 squared plus negative 5 squared, square root of 25, which goes back to 5, which should make sense if I connected that point. That vertical line would be 5 units long. Easy stuff, right? Questions so far? All right, then it said write the complex number in trig form. So for this, we need 2 parts, okay? The trig form, or z, would equal r times the cosine of theta plus I times the sine of theta. And we need to find r by doing the square root of a squared plus b squared, just like it's a radius, just like it's a triangle, all those things overlap. And then we find the tangent of theta to be b over a, or opposite over adjacent. And then we say, what's the tangent negative 1 of b over a? And we're going to find theta in radians. So this goes back to the unit circling. So 3 says negative 5i. So r would be 0, the square root of 0 squared plus negative 5 squared. We already found this to be the square root of 25, which is 5. That's the radius. And then the tangent of theta would be negative 5 over 0. What happens when you divide by 0? Undefined. Where on my unit circle is tangent undefined? There's 2 answers, right? Pi over 2 and 3 pi over 2. How do I know which one to pick?
It's negative on the imaginary.
Good. This is negative 5i, so it would have been plotted down here, which means I'm going to choose that theta is 3 pi over 2. So then z equals 5 for my radius times the cosine of 3 pi over 2 plus I times the sine of 3 pi over 2. Yep.
Do we have to write z equals, or can we just...
If you give me that 5, I'm not going to mark it wrong. Yeah. Questions? Yep.
So from tan negative 5 over tangent equals negative 5 over 0 equals undefined, how did you get to theta?
So now you're working in reverse. Like you're saying if tangent's undefined, what angles are we looking at? And tangent's undefined at pi over 2 and 3 pi over 2. But because this is 0, negative 5, I know I'm going to go down to the bottom angle. So there's always going to be 2 answers for the tangent. You would figure out which one there is based on where the little original location of that coordinate point is.
Okay, so it's either 3 pi over 2 or what?
Or pi over 2.
But you end up thinking 3 pi over 2.
Because it's 0, negative 5. So I would have gone down 5 instead of up. All right, then 4 said 1 plus I, which means both A and B are 1. This would be 1 here. So R is going to be equal to the square root of 1 squared plus 1 squared, or the square root of 2. And then the tangent of theta would be 1 over 1, which is 1. And again, 2 places tangent is positive 1. What are they? Pi over 4?
5 pi over 4.
Good, 5 pi over 4. So because this is 1, 1, which one am I going to pick? Pi over 4. So theta is pi over 4. And then I would get the square root of 2 times the cosine of pi over 4 plus I times the sine of pi over 4. So be really careful because this is going to be very tempting to type that in a calculator. And if you do tangent negative 1 of 1, it's going to give you a decimal. It doesn't give it back to you in pi over 4. First of all, you're in degrees because you did all the other stuff in degrees. Second of all, it's going to give you a decimal, and you don't want a decimal. Again, unless it says to round, you're keeping these answers exact. It doesn't mean you can't check it the other way. Like I can plug that in and check it. I'd have to be in radians, but I could check it. Which I think, Mackenzie, that was the question on the homework, is how do you get back from this to the other one, you mean? Yeah. So think about what happens at cosine of pi over 4, right? At pi over 4, it's root 2 over 2 and root 2 over 2. So I'd get square root 2. If I wanted to check it or go backwards, this would be square root 2 over 2 plus I square root 2 over 2. Distribute that in. Root 2 times root 2 is 2. And then this is 1 plus I times 1, or 1 plus I. So it would be how you check, right, or work backwards to make sure it's right. You're welcome.
There was one where it was like, get the standard form from the complex.
So that's what it means. Yep. Standard form is your A plus BI, and then trig form is your ones with the angles. Yep.
And then graphing is literally kind of like
Plotting a point.
Beginning. Okay.
Yep. Just be careful with your signs, that's all.
Okay.
Yeah.
It's just a bunch of like, how do you say, like formulas and stuff.
Sort of, yeah. Mm-hmm. Everybody's good? Okay, so for the sake of time, the first thing we're going to do is talk about the general topics, and then if I need to work out examples, I'll go back to them, okay? But I want to make sure we talk about everything that's on here so that you're kind of like fresh on what you should know. Yes, of course. All right, so the first section we talked about was law of sines. Remember that there was two types of triangles in law of sines. One where you got given the two angles and the non-included side. So if you're given angle side, then we use law of sines. You find the last angle, and then you set up your ratios. You cross multiply and divide. Then there was the one where you got given two sides and the non-included angle, and that's where you could have an ambiguous case. So we test to see, remember there was three options for ambiguous case. One where you get one triangle, one where you get lucky, you get no triangle, and one where you got two triangles, which I actually think was your quiz one, right? You guys said two triangles. Where you got to test for that second triangle. So again, we're going to talk first, and then I'll come back and work this example out, but I want to go through the overall topics first, right? And then in this section was also your area. Not there. Oh, yeah. Sorry. Area when you're given side angle side, which is at the top there. Okay, this is where you do 1/2 AB sine of C. Here's what happened on quizzes. People did 1/2. All right, 1/2 AB, people typed in cosine of C, right? So be careful. Remember that this came the very beginning. The beginning section was the sine, so you got to make sure you do sine. If you get two sides and the included angle, you literally just type that in 1/2 7 times 8 times the sine of 52, okay? Then came law of cosines. So law of cosines, the formulas were more complicated, but the actual, it wasn't as tricky, right? As long as you stuck to law of cosines, you were safe. So in these cases, you got side angle side, or you got side side side. And the trick there was to make sure that if you got side side side, you started with the largest angle first. Then you could switch to law of sines if you wanted to. If they gave you for side angle side the obtuse angle first, if the obtuse angle was given, then it was safe to switch to law of sines. If not, you have to keep with law of cosines the whole time. When in doubt, keep law of cosines the whole time. It's safer, okay? Again, silly mistakes are made on this stuff. We talked about it over and over again, but the cosine, when you're trying to find the angle, remember you have to group these in the top and the bottom. Otherwise, it's going to give you an error because the numerator will be bigger than the denominator, resulting in something bigger than 1, which you can't find the cosine of. With me so far?
Yes.
Again, I'll go back and work out these examples, but I want to go through topics first. Okay. Then came the area with law of cosines. On the next page. Yep. At the top, that's Heron's formula. So this one we find S by doing A plus B plus C over 2. Some of you divided by 3. That's wrong. It's over 2. And what do we make sure not to do with that? Don't round it. So I said it 8 million times and still it happened. Okay? Don't do that. You do not round the S. It will eventually terminate. It could be like 3 digits and a little annoying, but it will eventually terminate. And you need to keep it exact. And then the formula is A equals S times S minus A times S minus B times S minus C. You're welcome. And then you will get a word problem of either law of sines or law of cosines. So for timing purposes, if you get a triangle that's law of sines, you're probably going to get a word problem that's law of cosines. If you get the triangle that's law of cosines, you're probably getting a word problem that's law of sines. Okay, so I didn't do both. You just wouldn't be able to finish. Think about how long it took you to take your quiz, right? So remember to review those. There's some on the review, but we also did some leading into the quiz. That's a great review to do. All right, 6-3 was your vectors. So the good news is we just talked about a lot of this on the 3 warm-ups we just did. Component form of the vector and the magnitude. This is where we do terminal minus initial, and then terminal minus initial. And I would get -9, 11. And the magnitude, square root of a squared plus b squared, or the distance formula. In this case, it would be square root of -9 plus 11, 81, God bless you, plus 121. 202, and then I see if I can break that down, that would be 1, and that stops there. So these will be kept exact. You will not round those.
Let's put a square on it.
Oh, thank you.
Mathematical correction.
Thank you. What would I do with that?
I don't know.
All right, then state the following and state the result. Those are adding and subtracting. Are we okay on those? That's just like the warm-up, yes? Okay. Okay, component form of a vector with a magnitude of 7 that forms a 30-degree angle with the axis. So if I want to find the component form, then I would do the magnitude, right? So in this case, it would be 7 times the cosine of the angle, comma, the sine of the angle. So this is what I was talking about before when I said if it's in component form, it's got a comma. If it's in IJ format, then you would leave IJ, right? So this would be 7 times the cosine of 30, and then the sine of 30. 30 degrees, our coordinate point is √3/2 and 1/2. So I would do 7 times √3/2 and 1/2, and then distribute that in. So this would be 7 √3/2 and 7/2. Component form, so it gets little brackets.
So there's no I because it's not an I.
Correct. If it asks for it in IJ form, then I would just add in the I and the J. So it'd be 7 √3/2I plus 7 √2J. Like I would just add 7 √3/2I plus 7 /2J. That would be the only difference. Yeah. That's if it asks for an IJ format. Okay, then component form in unit vector. Remember, this is like the one that was on the warm-up, except that on the warm-up it asks for a different magnitude. Unit vector, we just do the component form of the vector over the magnitude of the vector. So this would be 1, 4 over the square root of 1 squared plus 4 squared. Or 1, 4, 1 plus 16, over the square root of 17, which gets split and rationalized. So if it's a unit vector, that's it. It's left alone. If it's not unit vector, it will say in the same direction, but it will give you a different magnitude, like the one that's below it and the one that was in the warm-up. And for those, we just distribute the magnitude in. So for that next one, we just take what we just found because it's the same one, and I do 5 times it. Which would be 5 √17 over 17 and 20 √17 over 17. So read the question carefully. If it says the word unit vector, there's no magnitude being multiplied in at the end. If it does not say unit vector and it says component form of the vector, same direction with the magnitude blank, then you're going to find your unit vector first and then distribute that magnitude in at the end. Okay. Okay, then we did the graph. So on the left, there's the graph below, just like the warm-up. Remember, if it said 4V, that means I'm going to take the V. I'm going to quadruple its length. 1, 2, 3, 4, and then to find the sum, I'm going to extend this out. I'm going to extend this out. Where they meet is the terminal point of the vector. That would be their sum. And then you had some vector word problems in here, which throw you off because of the language of them, but really they're just right triangle trig problems, okay? So I screenshot the one that had a lot of questions on the homework. So this was number, I just covered it up. Hang on. 14, okay? And it said a ball is thrown with an initial velocity of v feet per second at an angle of theta with the horizontal. Find the vertical and horizontal components of the velocity. So velocity, it can be broken down into horizontal, vertical, right? If it's horizontal, it's your x. If it's vertical, it's your y, right? Horizontal, x, vertical, y. With me so far? Yeah. So the drawing may not be there, and you'll have to draw it. If it makes an angle with the horizontal, then theta goes here, which in this case was 40 degrees. And the velocity makes up your radius, okay? So if your velocity is v feet per second, in this case it said 70, then I put the 70 on the hypotenuse. I close in my right triangle. This is my vertical. This is my horizontal. And I basically can just set up two trig statements, right? So if I want to find x and I've got 70, that's adjacent and hypotenuse. So that's saying cosine. It would be the cosine of 40 equals x over 70. And if I want to find y, that's opposite, and I have the hypotenuse, so that's sine of 40 equals y over 70. So all I have to do here is 70 times the cosine of 40, and here's 70 times the sine of 40. And that will give you your horizontal and your vertical component, okay? Don't be afraid of different wording. It's the same concept that you've been doing over and over again. This is right triangle trig, SOHCAHTOA, easy stuff, okay? These will be rounded to the nearest, it'll probably say, I don't know if it's 2 decimal places or 1, but pay attention to the direction. These are ones in which you will use your calculator. So this would have been 53.62, because it said around to the nearest 10th, or 100th. And then 70 sine of 40, and this is 44.99, which rounds to 45.
So how do you put 70 on the hypotenuse?
Velocity is like if it's getting shot up, right? Velocity is going to be your feet per second, or the distance traveled in that direction. So if it's going up at an angle, right? Velocity is always going to be your hypotenuse because it's going up in that direction. Does that make sense?
Yeah.
Okay. All right, then came dot product. We're good on all this stuff, right? We just talked about it. Dot product, angle between, and then orthogonal or parallel vectors. Yeah, everybody's okay on that stuff? And then 6.5, what's your complex number? Okay, there's only graphing, absolute value, and then find the trig form. That's it. There's only 3 concepts in there, okay? So that's everything. Understand?
Yes.
Questions?
No.
Okay.